Good day everyone, my name is Kozaway. Today I want to present for my final project and the project title are Predictive Analytics on Stock Market Index. First of all, I want to thank Dr. Pang to give me a lot of help during this whole final project. Now let me do some introduction for this project. The reason I focus on the stock market are because the stock market data is time series and the historical data will increase over the time. If we want to analyze the data, we need to spend a lot of time and effort on the data processing, data selection, and plotting the graph with manual. Besides that, the financial professional use the forecasting to make financial plan, but this moment predict the stock market index price without proper forecasting method. And for this research, I choose the predictive model which are ARIMA for study. These are the problem statements I have found out before starting the project. The exponential growth of the historical stock market index data, like what I have mentioned before, the pre-processing to extract the huge volume of data become a challenge for analyze. The larger the data, the more the time to process to receive our result. Besides that, why I choose ARIMA and not machine learning algorithm for this project? This is because the machine learning need to understand deeper in statistics and requirement for dataset are very huge and more feature. Hence, for my level, I'm not able to achieve that kinds of testing yet. The financial daily report need to spend a lot of time and effort to plot out the graph and the predictive result. Hence, the objective for this research are generate the automation Python script to extract the historical stock index data automatic. This is able to save a lot of time for pre-data processing. Second, to study and apply ARIMA model to make prediction about the future price outcome based on the daily historical data. Finally, to develop an interactive graphic interface to visualize the forecasting data, which means that everyone able to see the data and forecasting result on the dashboard. These are the methodology I use in this project. First, we know the problem of the historical stock market data are very huge. Then we define our goal, identify the data we needed, then do the data processing which are automation crunching our data set and do the training set and evaluate with the test set data predictive model. After that, visualize our result. This is the scope and data for this research. Field study I study for Standard and Poor 500 index, and the data set are we crunching from year 2000 until current. However, the data are flexible select for this project. We choose 2020 start until today for this research purpose. For this part, I just refresh the objective one for this research. So the objective one is to generate the automation Python script to extract the historical stock index price data for analyze. Then after that, I will show you how this automation Python script look like. Before we create our automation Python script, we need to know what are the things we need to do so that this script able to automatic crunching the and receive the data for us. First, we need to prepare the environment pre-processing and data pre-processing. This environment pre-processing is generate the folder and receive the current folder location. What the meaning receive the current file location, which means that after the data processing, I get all the data and filter all the blank column and do all the data pre-processing. I able to know this data need to save in which folder. These are the example before and after we run the Python automation script. Before that, the data are not existing yet. After run, the data are saved or automatic saved in this data folder. Now let me show you how to use the Python automation script. Just simply click this run script batch file. This batch file will automatically create all the folder and extract and pre-processing all the data and save into the folder. For this one, or the automation Python script was saved in this country dummy. So we click on this one. The Python script automatic help us pre-processing the data and save into this folder. These are the US dollar.csv, which means store the US dollar historical data. Before we waiting for standard and poor 500 historical data, let us look at this folder. Why from this we can see why the data are not the latest one, because I split the data into 2 times if you are first time running, so that the data will not get in 1 time. So suitable for every PC, else processing all the data in 1 time will make the computer lag or server hanging. So now we get our sender and poor data. You can see these are all the historical data. If you are first time running, the data will show us this new data have saved into CSV. Okay, now for example, let's say I want to this one A50 is not also latest one, only the US dollar. Maybe this data is too huge. So for testing purpose, we can delete this one. Then we run the Python script. Okay, we can compare the data. Now just now is this one is 2019 until May. So after second run, the data update already. You see already get the latest one. Then the outcome shows is all data existing for append, which means that this is not the first time running. For SP500, just now we delete already, so SP500. This download speed is attend from depend on your internet and CPU processing the to make the pre-processing. You see now the different one is append, one is the new data, which means that for the next day we using the Windows task schedulers run, all the data are append and not the first time running it already. Now this is the demo how the automation Python script run. After we done the data pre-processing, we need to know what are the steps we need for build the ARIMA model. For first one, we need to make sure the time series data are stationary, which means that after the user select the data set, we need to make the data stationary, so that we can process our step 2 to which are identify the AR and moving auto regression and the moving average model, so that we can we can move forward to step 3 to make estimation and forecasting. Then we use the 80% as our trend data and 20% for our test data. For this residual error, I just told you that what are the type what are the graph look like are the accepted for our model. If the graph look skewed to the left and or right, then we need to reject our model and reselect the data, or select the AR model and moving average model and pass into our ARIMA model. Else, if the graph look like bell shape like this one, then we accept our model. We can able to use this model to make our prediction. I will show you later in demo. These are the model prediction. Just now we have shown take the 80% for trend data and 20% for test data. These are the test data prediction and the compare with the test data. Then how, as a user, how I know this model are able to accept then with a high accuracy? By using R square, we know this R square show 76% compared to the real data, which means that the higher the R square value, which means that this model will show you a high accuracy for forecasting. Model is the forecasting result. Okay, now let me show how the dashboard look like. Okay, here is ARIMA model. We pick ARIMA model. From this, a user able to select the stock market index they want to do the forecasting by using ARIMA model, and they can select the times range. Uh, not not state that this time is need for 200. They can for all data, which data we have, we can select from here, which means that you see, okay, I can pick for 19, then I click confirm. Okay, these are the these are the graph look like for 2019 until 200. Let's say for this demo we don't need too much data. I just click for 2020. Okay, the data changed already. Now these are the overall all the daily open, high, low and close, and block the candlestick to show the overall all the data user pick and show in this graph. These are box plot analysis. From this box plot analysis, we're able to see the which are the median in all this data, which means that for analysis purpose, we can see all the data, which means that the price is closing with Q1 and between Q3, so that if over Q1 higher than Q3 we can sell, and then below than Q1 we can buy. So from this statistical analysis we can see, or from this we can know how many days we choose is 137 137 candle is shown here, which are the market data. Then we can see the mean, standard deviation, mean, max. Then these are the reference and the suggestion. I suggest this the last closing price is from 3226, and the tech if you want to, by using this Q1, Q2 and Q3 as reference, you can see, okay, now let's say we short sell, then 75% can be a take profit, and 50% as second take profit, and for long-term purpose, and we can choose the more 25% is 2846. Okay, this also help us count all the up candle, which mean green color one, and the down candle have how many, is 76 and 60. Okay, before we apply the ARIMA model, we must make sure the data is stationary. So how to process the data becomes stationary? We use the first order differentiation and second order differentiation. Why here we only choose for first order and second order differentiation? This is because the more order differentiation we do, the data will lose the information. What mean the first order differentiation? First order differentiation is take the first and the second and minus the difference between this candle. For second order is the second one minus with the first one. So now we can make sure our data is stationary. The data are between the 200, between this range, not like suddenly drop down very sharp and then go up very sharp. Okay, Now generated by using this first order differentiation data, user able to choose. They no need no too much mathematics behind. They just apply and using this dashboard to generate their prediction result. Generate ACF and PSCF. Using uh, this uh, this autocorrelation with 20 lag, which means that from this data, that lag one mean the all the data compared with the uh, the the next data set, and make the correlation. Then these are the zero lag, these are one lag, two lag, and three lag. For ARIMA model, for AR model, and auto regression model, and moving average model, for from here we can see ACF mean auto correlation model. Auto correlation model are matched for MA, which means that the ACF attend towards zero. Okay, from here we can see MA cut off after leg Q, which means that this we pick for MA, this Q value, the cut off after leg Q mean the value are drop below this 0.5. So we can pick 1 or 2 or 3, or the after this one, the data already the data able to use. For partial correlation is for AR model towards zero, cut off after leg Q. So for this one, the S this one cut the PSCF cut off after leg Q is 1, then SCF towards 0, which means that you see after this one the data towards 0. So we're able to choose 1 and 1 as our model, ARIMA model, p value and q value. Then by using before that, we need to double check for our model is really have relationship or not. So by using this Langbox test, the p value for leg 1, leg 2, leg 3, leg 4, and leg 5, I pick 5 only because normally we use until 5, not more than 10 lah. So this one, all the value are below than 0.05, so we accept this model. Okay, now we pick AR value as 1, MA value as 1. Forecasting day, I need to forecast for next 20 days, and the coefficient alpha I put 0.1 lah. Generate the model. Or from here we can see what are the how to pick p value greater than, lower than, what are the meaning lah. You can user can click here. The data are independent distribution, the data are not independent. After that, these are the ARIMA model result. We need to check the residual error. If this residual shows the bell shape, which means that this result are normal distribution. Then the model prediction vs the real data, we need to check how many percentage difference between this real data and prediction data we using the outspread. User no need to uh, check so much. They just need to see the outspread value greater than 0. Outspread value is between 0 and 1, so this 0.7 mean these two prediction and real are have very similar, very close, so this prediction value able to this model able to use. So by using this one, user can see the data after for the next day. They can pick the red color one, meaning the up the upper one, this red color one as their stop loss or their take profit price, and the bottom one as also lah, will see whether you are buying or selling. So these are the forecasting result. Thank you. In this research, I have faced some limitation. The first limitation is difficult to link other than the closing price factor into ARIMA equation, which means that I can use only one feature data which are closing price. We cannot combine the closing price, open price, or some other feature into this ARIMA model. Besides that, I have lack of support on the economy factor. The third one is difficult to get the data for every minute to make forecasting. I can only get the daily data. In conclusion, ARIMA model provide a useful tool for data scientists to develop and generate predictive results to support economic analysis. This research is achieved to develop of the automation data processing to study predictive model on stock market. Thank you.